Okay, today, in this video, we're going to talk about number sets. Okay, so there's a few number sets that we're going to be looking at in this course, and they're all listed right here. So we'll start with the first one called the natural numbers. Now, the natural numbers, we can think of the set of natural numbers, and we denote this set by this funny looking n. The natural numbers are the numbers we count with. For instance, 1, 2, 3, 4, and they keep going all the way as high as you can count and then some. So these are the numbers we observe. We observe these numbers in nature. That's why they're called the natural numbers. Let's talk about the whole numbers now. The whole numbers actually are just an extension of the natural numbers. The only extension is the addition of one extra number, and that is 0. And then we still have all of these positive numbers here, like that. So that's the whole numbers. Okay, notice the natural numbers are contained within the whole numbers. Okay, the next set is called the integers, and we denote the integers with this funny looking z. And these integers consist of the whole numbers, so 0, 1, 2, 3, 4, and so on, as well as the negative of these whole numbers. And they can go as negative as you want. So these are the integers. Notice, again, the integers consist of the whole numbers. And we've added more, just like the whole numbers consisted of the natural numbers and so on. Okay, now let's talk about the rational numbers. The rational numbers was this funny looking Q. And this one's a little different. It's the set of all numbers that can be written as a fraction. Okay, so we're going to now have the fractions. So this is the set of numbers of the form A over B, where let me fix that, where A and B are integers. So the numbers that we have in this fraction are specifically from the set of integers. And there's one catch. B can't be 0. Okay, we can't divide by 0. Remember, this horizontal line here represents a division. Okay, so examples of rational numbers would be like 1/2, 3 over 2. In fact, an integer, 2, well, all the integers are actual rational numbers because we could divide each of those by 1, and we don't change the number. So the rational numbers actually contain the integers. Okay? So notice what's happening here. As we define each set, the previous set is contained within the set before. The previous set is contained in the next set until we get to the irrational numbers here. Okay, so the irrational numbers. What are the irrational numbers? Well, first of all, we denote them with this Q with a C. The C means complement, and we'll discuss that some other time. But the irrational numbers is the set of all numbers which are not rational. So this is, any number in this set is not in the previous set. Okay? So any numbers which are not rational. So any number which can't be written as a fraction. So numbers like in this set include numbers that you know of, like pi. You've seen the square root of 2. There's another number here which we'll talk about later, e. There are an infinite number of these irrational numbers. Okay, and one thing that these have, which helps define these, is that they contain an infinite number of decimal places that don't repeat. So what do I mean by that? Well, one of the rational numbers is a third, and if we convert a third to decimal, it's 0.333 and so on and so forth. The 3 repeats. For irrational numbers, they all have an infinite number of digits which don't repeat. Okay? So I encourage you to look up, for instance, the number pi and print out its first 1,000 digits, and you'll see they never repeat. Okay, finally, we talk about one more set, and that's the real numbers. We denote it with this funny looking R. And the real numbers actually consists of the previous two. It consists of all the rational numbers and all of the irrational numbers. Okay? So the real numbers contain everything that appears on this screen. All right, so this is just a quick review of our number sets. I hope you find this helpful.